All right, so we have a method by which we can compute the slope of a tangent line. Given a function, you compute this limit, and upon running the computation there, which is often technical, tedious, laborious, but the long story short is you can come out the other side with an expression for the slope of the tangent line. So one thing that can become common, because the act of going through this process is long, good to know, but like, what can you do about it if, say, you were given what the derivatives expression was already? So in this case, when we have a function x cubed plus 4x squared minus 1, now you know you could take this function, run it through the derivative, and what would pop out would be an expression for the slope of the tangent line. Well, this problem is telling you that when the original function is so, its derivative is just 3x squared plus 8x. So they've already told you the derivative. They've told you what the expression is for the slope of the tangent lines. And what they want you to do is find the equation of the tangent line at the point 1, 4. Here's the thing to think about. This point 1, 4 is a point on this function. And you know at any point on any function, if you zoom in, you'll get a tangent line. And you also know that any line has an equation associated with it. The equation of any line, like our tangent line, is going to be something of the form y equals mx plus b. Because, well, every non-vertical line has an expression of the form y equals mx plus b. So we're going to exploit that here, and we're going to ultimately, if we're going to find the equation of our tangent line, we're going to find an equation of a line, which has got to be in the form y equals mx plus b. So the challenge is going to be to find m and to find b. Now here's the thing to think about. We know that this tangent line goes through that point. And if you think about this in general, when you talk about a line through a given point, I guess this point is what, over 1 up 4. There are infinitely many lines through that point. But if you want to know precisely the line that we're talking about, well, if you also knew the slope, there's only one line it could be. Because if you imagine a line through this point that has a particular slope, whatever that slope is, say the slope is, well, who knows what the slope is, but imagine a slope, say some positive value, whatever it is. Well, if the slope is whatever the slope is, once you have a point and once you have a slope, the line is fixed. Because to be a different line through that point, you'd have to have a different slope, either more positively sloped or less positively sloped, maybe even negatively sloped. But the long story short, your slope would have to be either greater or lesser to be a different line. If you are going through a particular point and you have a particular slope, there's only one line you can be. So we know the point of interest, 1, 4. If we knew the slope of interest, we'd have everything we need to solve the problem. So the point is 1, 4, and the challenge now is finding the slope. We want to know the equation of the tangent line. Do we have a method to find the slope of a tangent line? And the answer is yes. The slope of the tangent line is given by the derivative, which fortunately has been stated directly for us. So since we know what the derivative is already, we know the slope of the tangent line at any point. Plug in any x. F prime tells you the slope of the tangent line at that x. So in our situation, we're interested in x equals 1. So we want to know the slope of the tangent line at x equals 1. That's going to be f prime of 1. The slope of the tangent line at x equals 1. Well, plug in, that's 3 times 1 squared plus 8 times 1. That's 3 plus 8. That's 11. So we know the slope of our tangent line is 11. And this tells you straight away that the equation of our tangent line is not y equals mx plus b. Now remember here, you've known this from your past, but m is the slope, b is the y-intercept. Well, if we know the slope to be 11, then our line is y equals 11x plus b. And we're so close to knowing the equation, we just now need to know b. And when you look at this expression, y equals 11x plus b, it'd be like, man, if we want to know what b is, it'd be really nice if we knew x and y. Because if we knew x and y, we'd know exactly what b is, because that would be the only unknown remaining. And then you could ask yourself, do you know an x and a y? And the answer is yes. You know an x and a y. You have the point 1 comma 4. The x is 1, the y is 4. So using our point 1 comma 4, plugging in 4 for y, 1 for x, using our slope of 11, y equals mx plus b turns out to be 4 equals 11 plus b. Well, you know if you want to get b by itself here and 11 is being added to it, you could subtract 11 from both sides. So minus 7 is b. You know the slope, 11. You know the y-intercept, minus 7. You know the line, y equals 11x minus 7. The long story short is, if you are given information about the derivative, like you know you could compute this, it would be long, tedious, laborious. But if you're given that information straight away, then you can actually say a lot about what's going on, because the tangent line at this point is not any line. It is the particular line at that point with the particular slope that is dictated by the derivative, and whenever you run the numbers on that, you can actually determine exactly what that equation is.